All right. Can you hear me at the back? Oh, more people are coming. Let's wait 2 minutes. Okay, so this is comp 5630, 6630, and the distance section. If you are not enrolled in one of these courses, then this is not the right place. Okay. I know there are some people who are just auditing. Yeah, you can go ahead. Have not yet registered, that's fine. But if you are not here for machine learning, then you are in the wrong place. My name is Shubhro Kanti Karmakar. I know you cannot pronounce it, and that's okay. You can just call me Shontu. You see the name in the bracket, and that's how I go by. So just call me Shontu, okay? Today we are just going to talk a little bit about this course. The overview. We're not going to go over any technical materials today. It's just an introduction class. We will be talking about what you still don't know, but you will probably know, at least I hope that you will know at the end of this course. That doesn't always happen, but this is the goal, okay? All right. So before we start, can you tell me like who are not yet officially enrolled, but just auditing right now? 1, 2, 3. That's it? 4, 5. Okay. All right. So hopefully I can scare you enough through this lecture so that you will not enroll. Okay? That's the goal. All right. So yes, that's what I have not told you yet. Another purpose of this class today is to scare you. So that you drop the course. Okay? No? We will see, because I taught this course last year, and from my experience, it's good to scare you early enough so that you really know whether you are ready to take this course or not. Do you need to find some seats? Is there one empty? No? Is this one empty? No? I don't see one. Yes. You want to? Okay. Yeah. Sure. Yeah. Yeah. Sorry about that. Yeah. All right. Yeah, so as I was saying, it's better to know early if you're ready to take this course or not. So what I will be telling you, what you really need as your background to do well in this course, and you will be able to better judge yourself. If I'm not able to scare you enough today, I have another way to do it. We have an assignment number 0 that is already released, and then you have to kind of go through the assignment to really judge whether you are ready to take this course. And even after that, if you are not scared enough, welcome to machine learning, okay? Welcome. So again, this is a 3-credit course. It will be a more lecture style. You need more seats. No? Okay, one more seat has opened up here. The style of this course is mostly lecture-based, assignments, exams, and a decent size project. Okay, it's more like a traditional lecture-based course, and these are the topics we are going to cover. So before I talk about any of this, how many of you actually know about machine learning? How many of you think that you know about machine learning? How many of you have no idea what machine learning is? How many of you have used ChatGPT? How many of you have never used ChatGPT? Okay. How many of you have a bachelor in CS? How many of you are still pursuing your bachelor in CS? How many of you don't know what CS is? How many of you don't have a degree in CS or not pursuing a CS degree? All right, you see all the variations in this course. That's why it's very difficult, right? How do I manage the class? That has been a challenge in the last year. Let's see. I'm planning to do better this year. But all right, so we are going to start with what today's lecture is about, introduction to machine learning. Well, it's not about introduction, right? I told you, it's about scaring you today. Okay. Then we will actually get into the business from the next lecture. We'll be talking about decision trees. And decision tree is one popular classical supervised learning. And what is supervised learning? It's more like a teacher-student style, right? The teacher teaches something, the student learns it. There is an active supervision in the process. And we'll start with a decision tree that is one of the classical supervised learning approaches. But then we will go on to other approaches like naive-based classifiers, logistic regression, linear regression. And regression is definitely, the linear regression is not a classification problem, but it's a supervised learning problem. Then we will slightly drift to a new concept called regularization, which is very important for machine learning. It's not really directly about learning, but it's about enhancing the learning. And you see the evaluation and model selection, where we will talk about, okay, you learned something, but you really need to know how did you do in terms of learning. Was your learning job good? Did you do it very efficiently? Did you do it very effectively or not? How do you evaluate those models? And then we will shift towards linear separators, perceptrons. Although perceptron sounds very cool, like a robot kind of thing, it's the very basic neural network you can think of. How many of you have not heard the term neural network? Okay, everybody knows the term. Okay, so that's what we will get into from perceptron, and we will visit the support vector machines on the way, which is also a classic popular supervised learning algorithm, but probably no longer in use today. And we will discuss why. Why is not that so popular? Maybe some people are still using it, but not that much. So up until that point, everything is supervised. There is some supervision we'll be using through the learning process. But for the last two parts, where we don't have supervision, but we can still learn something, we can still recognize patterns. And that is going to be the unsupervised learning part that we'll be touching a little. I also had reinforcement learning last year, which I could not get into. So I just dropped it this year. Okay? But if it looks like you guys are making more progress than I can, for example, let's say I submit an assignment and you submit it tonight, right? then you need more contents. And I'm happy to introduce more. But I don't know if that's going to happen. So let's get back. Question? No? Okay. So let's get back to the question of what is machine learning. Right? What do you think machine learning is? I've told you a bunch of jargons and some terms that you see probably have no idea what they mean. But let me hear from you. What do you think? What is machine learning? Anyone?
Pattern recognition?
Pattern recognition. Do you think a pattern recognition is always machine learning?
No.
Okay, then you have contradicted yourself in some way. Yes?
Sometimes I think of it like a learning style, like how humans have learning styles and they process things and information in a certain way. I think of machine learning like creating an algorithm to process information in a certain way.
So, do you think it's like simulating the human brain?
No, just like a particular, like if a human brain has the adaptability to learn in any style, then machine learning has the ability to learn in whatever style you specify.
Okay, good. What else? Yeah.
Things like ChatGPT or the AI we already know as is considered machine learning because they use the same principles.
So AI and machine learning are the same?
Not necessarily, they use similar concepts.
Similar concepts, okay. What else?
Maybe it's the ability of the machine to learn from given data sets or something, from the given information, and draw the outcomes.
Okay. Yes.
Creating or developing a model and training it on a particular set of data to simulate the real-time data scenarios and using it to make sense of a huge data.
Okay. That is more like an applied like definition. Yeah. Sure. All right. So it looks like people have some idea and some general ideas, but there are also some probably confusions in terms of the terms that are used. For example, pattern recognition, very related term to machine learning. For example, AI, artificial intelligence. It's very related. They are very related terms. But it's good to think about what is different between them. For example, AI. It means artificial intelligence. So, and learning is also a form of intelligence, right? Because intelligent beings can only learn. Like people who are not intelligent, not about people like animals or creatures, they cannot learn properly, right? So, it's good to think about what is the overall landscape of machine learning and AI. So where do things like belong? So in terms of belonging, let me ask you this question. What do you think is AI or artificial intelligence a special type of learning? Or is learning a special type of intelligence?
The second.
The second? Anyone? Okay, so tell.
I think you learn intelligence, or machines learn intelligence. So if you want to have the pattern recognition example, we fed a lot of examples under a certain model to understand what it's looking for, to be able to recognize those patterns, and that's what gives you intelligence.
Okay. So can you, are you arguing that before you learn, you don't have any intelligence?
We have some, but
Okay. So the whole point is in general, I will tell you what the field of AI looks at these terminologies. Okay, we can always debate about what belongs to what, but in terms of AI is more like a general broad term. Anything other than humans or living animals that is kind of showing some kind of intelligent behavior is defined as artificially intelligent. Now, the definition of intelligence is debatable, right? What is intelligent? How much intelligence is actually intelligence? But what we are trying to do is to make those machines do tasks that you cannot do without having some form of intelligence that we define as humans. So under this broad umbrella of intelligence in general, for example, you will not be able to learn anything if you are not an intelligent being, right? So it's kind of the top hierarchy, the AI, and under the AI umbrella, you see many, many different tasks. Because if you are an intelligent being, you should be able to recognize patterns, what is happening. So pattern recognition is definitely something that falls under AI. Machine learning, you should be able to learn something if you are intelligent, right? You are taught, you see data, you gather experiences, and you learn because you are intelligent. Because if you are not intelligent, probably even if you go through a lot of experiences and data, you are not learning. That's kind of how intelligence is defined. So it's good to think about AI as the broader umbrella, and then learning, pattern recognition, kind of like under that umbrella. Questions? And then recognizing a pattern may not always mean that you are learning. It may mean that you have already learned that, but it's not that you are learning new things. You are just recognizing the difference. Well, often like the learning also involves pattern recognition, because by recognizing the pattern, you actually learn that this is something. So they are not separate. They kind of overlap a lot. Okay? So here is this confusion that happens all the time today because of how this field of machine learning has grown. Like people think machine learning as AI. It's kind of like it has become so popular that machine learning is kind of defining what AI is. But historically, AI did not mean machine learning entirely. It was machine learning was definitely a part of it. But now it has grown so big, like it's often interchangeably used with AI, which is not necessarily true. Okay? So the other branches of AI, what broader AI means, what that landscape is, that is not part of this course. That is something you are taught in the AI course. But in this course, we are specifically focused on machine learning, where we are trying to make machines learn based on experiences. And the experience is, in terms of computer, how can you represent experience? What is the representation of experience in terms of a computer? Yes?
Data.
Data, right? And data is number. So what is a big challenge in machine learning? If you are trying to learn from experiences, but in computers, there is no way to give experience. What is the big challenge?
Having a proper knowledge base.
Proper knowledge base. Okay?
Turning the situation you want into data.
Exactly. That's the biggest problem, right? Even if you are talking about knowledge base, that there is, computers don't understand knowledge. Computers only understand what?
Data.
Data. And data is what?
Info.
In computer,
Binary.
it's just a number, right? I mean, it's binary. If it's computer, maybe a quantum computer, maybe it's not binary, but still it's just numbers. So the biggest problem is convert your real life experiences into data. And yes, that's not all of your problem. It's not going to solve your entire problem, but that's a big problem. The next problem is once you have those data, then how do you convert that data into some useful labels? That is where the learning task comes. But the first task that we talked about is called feature construction. You want to construct features from the data that represents those real life events or experiences. So in this machine learning course, we'll be talking about how do you represent your data? How do you create an example data? How do you create labels on that? Because we, as humans, we learn by labeling things, right? We call that an, oh, that's a dog. We are labeling an animal. That's a cat. So the whole point of machine learning is to kind of categorize things, putting labels. If we cannot put labels, create artificial labels, right? So, all right, I think I'm good for now. Any questions? All right. So, coming back to the machine learning problem. So, if these are real life data, real life examples. Now, in order to do machine learning, what I need to do?
Say the model that this is a fish, this is a dog, and this is a cat.
How do I say it?
Different labeling.
Okay. So, does dog mean anything to the machine? What do I say?
If you see so and so pixels or so and so features in a picture, then you must know that it's a dog.
But dog doesn't have any meaning for computers.
Is this a name?
Right. So instead of dog, if I call this as like X, is that a problem? That's a problem? Why?
Because the computer will say it found X whenever it sees the picture.
Okay, but if you have a separate mapping like X is actually dog, then is the learning task is actually changing in any way? No. The learning task remains the same as long as you have a label for it. It doesn't matter what you call it, right? Okay, so what is the top fish?
It's a trout.
It's a trout. The top one?
Sure.
Sure. What is the bottom one?
Salmon.
The bottom one
Red
is salmon,
snapper.
and the top what? The top one is a salmon. Okay. What is the bottom one? Trout.
50-50.
Now, do you disagree?
I mean, if we put in Google, we could figure it out. I don't know.
Yeah. I got it from Google, so you can definitely figure it out. Right? So pattern recognition is not very easy, even for humans, right? You are disagreeing. You have already started to disagree. So it's also hard for machines, and these are like more real world images that we perceive through our senses, our eyes, and all with all the experience, and still that is like a little hard. For computers, it's even harder because you have to translate this salmon or trout or whatever you are claiming they are into
Data.
numbers, right? Into data first. Then you have to tell the computer that, hey, these are salmon or these are trouts. Then the machine will try to learn, oh, okay. So if these numbers make out salmon and there are many other numbers and there is some similarity or pattern in these numbers, that is what the machine is going to capture. And that is captured through an algorithm that is called a special kind of algorithm. called learning algorithm. So now the question is, what is algorithm? How many of you know what an algorithm is? How many of you don't know what is an algorithm? What about the rest? Okay, let me rephrase the question. What is input to an algorithm?
Numbers?
Numbers. What is output of an algorithm? Numbers. Good. What is input to an learning algorithm?
Data.
And data is number. Okay. What is output of a learning algorithm?
Numbers?
A label.
Maybe a classification.
Well, if it is numbers, then there is no difference between traditional algorithm and learning algorithm.
It's like smarter numbers.
Smarter numbers. I like that. Let's give it a name. We are in machine learning. We want to give it a name, a label. What is that?
Maybe a vector.
Intelligence. Yeah, close.
Probabilities.
Probabilities. Good. More generic.
Vector.
What?
Vector. A vector.
Vector. That is still a data. Classification. You mean the labels? Labels is also data. The output of a learning algorithm is another algorithm. See the difference? So far, if you have done CS, you are coding, you are implementing methods or algorithms. You have inputted data, you have got data. That's what algorithm does. It takes some input, data, process that, and then whatever logic you have, at the end of it, you get some data out of it. You do some transformation. It's a function. We are again writing a function, but the output format is no longer a data. It is what? Another algorithm.
A smarter algorithm.
Yes, I mean, that depends on the definition, but still an algorithm. And then what do we do with that algorithm? Give it new data. And what is going to be the output of that algorithm?
Another algorithm.
Data or algorithm?
Algorithm.
You gotta get data eventually, so.
It has got to be data eventually, because that's what you are trying to learn. Because you just don't want to, you don't know what the algorithm is going to be for the task you are going to do, right? Let's say, so here is the problem. If you know what you want to do, you write that, this is what you want to do, and you get Y. Simple algorithm, right? Traditional. But let's say you don't know how to convert X to Y. You don't even know how that works, right? But you have many different Y and X examples from real life you have seen. You know you want to convert, if you are given X1, you want to convert it to Y1. You know that. You just don't know how to convert it. Right? So basically, you don't know what this is. What machine learning does, learning algorithms, the input is this to data, and the output is this algorithm. You're trying to figure out what algorithm actually converts X to Y. And then once you have learned it, then you can feed it new X, xk. Let's say you don't know what Y is going to be, but if you even don't know, you can now compute it, right? Why? Because you know the algorithm now, which was the output of the learning algorithm. Is that clear? Any questions so far? Yes.
Is there a term for that algorithm that you've developed through the learning algorithm?
Learned algorithm.
Okay.
Whatever you know. Right? Yes. I mean, when you what is learning in that sense? Like if you say it's the definition that we are defining, it's some sort of logic, right? Some kind of what?
Did you call it a model? Is that something?
Yes, definitely that is a model. Yeah, yeah. The algorithm is the model, right? I mean, but then there are two different models here. One is the learning model, one is the output model, right? So it's good. It's very important to distinguish what is coming out of it is definitely not data. Now you can call it a model, sure. You can call it some kind of logic. In the broader term, you can call it what has been learned, the intelligence, the knowledge, right? Let's call it knowledge. That's a better term because based on knowledge, we can classify things. So let's call the output algorithm a knowledge, and we'll use that knowledge as models or like as a tool for future tasks. Questions? Yes.
So this example that you gave where you put an indice on the x and the y, when you put like x1 into your learning or your machine learning and you output the knowledge, could you also say that the knowledge has an indice such that the knowledge would be based on the input data?
Very good question. So we are now talking more about the characteristic of learning. So think about a person who has lived in a room for their entire life. That's all they have seen. That's all the data they have perceived. That's all their experience. And whatever they are going to like behave or like act on is going to be completely influenced by that room, whatever has happened over the time in that room. And that defines the entire space for that person. The same for machine learning. If your training data is so biased, so narrow, your machine is going to learn very narrow things because it hasn't seen the world. Whatever it has seen, it can only understand that. Well, there is a counter argument to that, like, okay, you want general intelligence, where as humans, we can generalize things, like based on a pattern from one domain, we can apply that and we can be more creative, which machines are not for sure today. Maybe someday they will be. But it's a very hard problem, even for humans. And for machines, this problem is far from being solved. We sometimes call it domain adaptation. And there are research on that. But if you kind of throw a completely, and that generalization also happens after you have some diverse experience. If you just have one experience, it's very hard to generalize. So it depends on how diverse your training data set is. Based on that, you could probably enhance your generalization capability. That's another core goal of machine learning, generalize things. If I give you just one room and give you some data, what about what is happening in the other room? Right? Can you predict that? To better know that, you probably want many, many rooms to be sampled first. And then you will have a better sense of what is going to happen in the next room. But if you are just given one room and then a completely different room, you are probably going to not predict what is happening. Right? Yes?
You were saying learning algorithm. So training and testing are both learning algorithm inside the learning algorithm, or the testing will be the knowledge part?
Yes. So this is what I described is actually the training testing paradigm that you just mentioned. So the first part, when you were learning, that is the training, where you are actually learning an algorithm. After the training finishes, what you get is the knowledge, the other algorithm. In the testing part, you test that knowledge, that algorithm on some other data that you haven't seen during training. And why we don't want the testing data to be included in the training, because we want to see how general this algorithm has become. how good it is at classifying things or recognizing patterns on data that it has not seen yet. Okay? All right. Okay, so back to the quiz. The top one was the salmon, and the bottom one is the trout. Okay? All right. So I'm not going to give you like big details on the topics that we are going to learn. Just a brief kind of name things. It's completely fine if you don't understand a single thing from now on what I say. And that's okay. But it's good to know the terms that are coming next during the lectures. The first one we are going to learn is some kind of decision tree. So remember this box. If we don't, for sure, we don't know what this box is. But even if we don't know something, we need to assume something, right? If I say it's a black box, it's a completely hollow, it's empty box, then that doesn't work, because you need to. Yes, you are trying to learn an algorithm, but algorithm space is infinite, right? How many algorithms you can devise? That is infinite. All the possible ways of defining an algorithm, right? So you need to track down this problem. You need to make it computationally feasible. In order to do that, you need to assume some kind of form of that algorithm. You need to assume a particular family of algorithm, a particular family of function to make it tractable. So maybe that's a linear function. Let's say function of x is ax plus b o y plus c. Let's say xy, right? What does that mean? That means the box that we don't know, we are now assuming that box actually is of the form of this, where x and y are data, right? Now we have drastically reduced the amount of the space of the possible different algorithms this box can take. We just need to learn, we have shrink down the problem of learning to just learning these three things, A, B, and C, because we don't know what they are, right? So now we have shrink down, and our whole learning problem has converted to figuring out this A, B, and C. Based on a lot of examples of x, y, and function of x, y. So in decision tree, what we assume that this box is a tree. It's a tree of decisions based on attributes and attributes of the data. You are going to learn a tree to make a decision. And that's what we do as humans a lot of time. For example, think about this tree and tell me if it is not overcast, what is Alex going to do? Is he going to play tennis or no? Right. There is no decision, right? What about if there is a strong wind and it is raining? What will happen? No. Right? So based on this tree, you can construct different logics. And you can decide based on tree. By the way, anybody is Alex here? No? We had an Alex in the last class. So I always used to point at him, tell me, like, are we going to play or not? But not this time. Okay. So in some cases you have a clear decision, in some cases you don't. But this is one way of creating a knowledge or creating an algorithm. This is still an algorithm, right? This is an if-else algorithm that you can devise from it. For example, what? If Outlook equals Overcast, then yes, right? Else if, and so on. You could go down the tree and you could write an algorithm, right? No? So what we are now going to show is, if you assume different forms of this box that we don't know, we end up with different learning algorithms. We are just assuming different representations because we cannot assume all representations. That will mean we need forever to compute. Unless we hack into the space-time and we are in a black hole, time stopped, you can keep doing what you are doing. Right? All right. So next one we are going to learn is Nye Bayes classifier. Now that box changes from a tree to a Bayesian posterior. How many of you have studied Bayesian probabilities? How many of you have never studied Bayesian? How many of you are confused about Bayesian, like what it does? Okay, so warning sign. If Bayesian is something that is not clear, you will struggle in this course. A lot of things will be based on Bayesian. So, you really want to convince yourself you know Bayesian very well. Okay, probabilities. Yes?
Can you explain Bayesian, like the term? Because I mean, I hear terms, but I don't really know like what they actually mean or what they
Sure.
are.
That is Bayesian. Okay? Now, the point is, what does that mean? Let's talk about two different
I mean, I
you see the H? Anybody knows what H stands for? Hypothesis, right. What is E?
Evidence.
Evidence.
It's evidence. Now tell me, I have also talked about these two things, but I probably named them a little different. What are they? What is E for me?
X, your data.
Data. So E and D, this is data. So this is general Bayesian term, but when it comes to machine learning, we just talk about data. What is this?
Algorithm.
The algorithm, right? Right. So what Bayesian is trying to figure out, given probability, because we are searching through a space of algorithms, right? That is what our output is. There are many different algorithms. I just want to find one, or maybe like not 5 million, maybe 5 max. I want to make it tractable. But let's stick to one for now. We just want to learn one algorithm. What is that? H. Given E. E is my data. Given data, I want to learn how likely is a particular algorithm. What fits this data? Based on this data, what is the most likely algorithm that explains it? That's what I am trying to learn. And definitely I have to try many different H before I can decide on which H is appropriate. And how do we decide that? Which H is more appropriate?
It's from training database.
Yes, but in terms of number, what does that mean?
One which is closest to 1 is the best outcome.
So the highest probability, right? The hypothesis that gives you the highest probability is probably the most likely one. Sometimes we don't do that. the highest one. Maybe we do some tricks there, but let's forget that. Let's make things simple for now. So what Bayesian is trying to do is computing these probabilities, and then based on those probabilities, try to find out what is the most likely hypothesis. Does that answer your question? All right. More questions? Okay, the next one. Now it's called a logistic regression. Now this box becomes an exponential function rather than a just probability. And there is a specific formula for that. We will learn that. But the whole point is, each topic you are seeing is just talking about a different assumption about this underlying algorithm. Different forms of knowledge. Different forms of the model. Okay? Linear regression. How many of you have done this? This is Stat 101, right? You know, given some data, you want to fit some lines, some curves. That is also learning. Because you are not covering everything, you are kind of generalizing the pattern. Right? So regression is one form of learning. Okay. Now, we have talked about some different forms of learning, but let's try to now think about what is good learning versus bad learning. What is good learning?
You can give the correct output consistently.
What is correct?
Like if I ask you what that picture of a dog was and you told me it was a cat, that's incorrect, but if you said dog, it was correct.
Okay. But let's say I write an essay.
Okay.
And I have two essays. Which one is better?
Oh, okay. You said
Because your task is to learn to write. Let's
right.
say.
Well, maybe
Satisfy the rules. What are the rules?
grammatical rules.
So the point you see, it becomes complicated. Right? The evaluation. At some point, like for straightforward tasks like cat and dog, it's easy to evaluate. You know, yes, no, done. But when the task becomes more complex, the evaluation becomes more complex. Sorry?
Having a least error.
Having a
The least error.
least error. Okay, but then what is error in writing?
Do you mean like content-based?
Content-based. So it has to relate to topic.
Right.
How do you decide how much related to topic, how much it is related to a particular topic? If I ask two different people and ask it to rate from 1 to 10, will they agree? Can you guarantee?
No.
No. Yeah. That's the problem. There are ways to like overcome that, but I'm just saying what is good learning and what is bad learning is a philosophical question. Well, this is another trick that scientists do. When they cannot solve the problem, they just say this is a philosophical question. This is not our job. Right? Blame it to someone else. But that's true. It's hard. We have to make some assumptions and we have to just be okay with that assumption. Sometimes some assumptions we cannot just get rid of. So in a lot of models and in a lot of learning tasks, we will make a lot of assumptions. So another goal of this course, besides scaring you, is to learn those assumptions, being able to recognize those assumptions and kind of teach you to live with those assumptions, be okay with those assumptions of machine learning. And that will also explain why machine learning fails in many cases, because those assumptions are wrong. Because all these models when we are doing, for example, the decision tree, what are we assuming?
Makes sense.
Well, we are assuming there is a bunch of if and else rules in the form of a tree. Maybe that assumption is not true always. If you go down the path of a tree, you cannot go back to the other route. Maybe that's not a correct assumption. But sometimes Okay, here is the thing I want to tell you. Every model is wrong in some way. Some models are useful. And the goal of this course is to learn ways to learn those useful models. So what you are trying to do in this course is trying to learn to learn. It's like a meta-learning process. So with this like good and bad learning question comes these things called overfitting and regularization that you will see coming up in the course. So look at this one. We call it overfitting. Is that a good thing?
No.
And that one on the right, is that the right one? Is that good?
Depends on the problem.
Depends on the problem. Good. Which one is better?
Depends. I need more data.
It depends, right? But you see the issue here. One is trying to fit every point, which is probably one extreme. And you see like just a plain polynomial kind of thing. This is probably too simplistic. So there is a tension here. There is a trade-off here. This one is more generalizable, right? Because in this case, your algorithm has too much variance. The outputs you are going to get are going to be wide. That one is more stable. But then depends on your application domain, like which one is that you really need. And that's where you need to test on unseen data. Because just fitting your training data is not probably good unless you see more data on the testing and test on them and see exactly what it does. So not always learning to capture every corner of your space is a good idea. And we will talk about ways mathematically doing this and having computers some constraints to do this. We will talk about ways to do it, but this is the concept we are going to repeatedly talk about in this course. This is central to machine learning. Okay? Questions? How many of you are scared so far? 1, 2. Oh, I'm doing a very bad job. Okay, let's see. Linear separators. So, and then again, we are going to, coming back to the models, we can learn another kind of model that kind of maximizes the separation between two different labels of data. And we are going to learn hyperplanes. And that's why I keep telling probability statistics, these things will be coming back and back. And even if you are from computer science and you don't think you have a solid background there, you want to rethink if you are ready. I'm not saying you cannot take it, but then you have to put additional effort to make up for those backgrounds. You really need that in this course. Okay? And we will not have time to cover those basics. That's the problem. Okay, so linear separator, have a linear plane, try to divide labels. What is the problem with this? This kind of model.
Might not be like separable like linearly.
Exactly. Not always you will find a like linear line that separates things, right? When things are more complicated. So linear separation is simple, but it does not solve the problem always because there are more complex problems. And real life, trust me, data is always complex. Right? And that is what we will also learn through the project when you shift from a regular data set to a real life data set. What additional challenges you see. How quickly your accuracy drops. But there is a thing called kernel trick that we are going to teach you. And that helps you solve those kind of non-linear problems. but converting them into linear problems and then solve. Because, okay, let's assume that I cannot learn non-linear things. I can only learn linear from linear data. Then one option is to transform your data into a linear space, maybe at a higher dimension, and then learn a linear space, right? So those are called kernel tricks, and we will cover those. And extending on that idea, we'll teach support vector machine that tries to maximize this margin between two different labels. So dogs should be farther away from cat as much as possible, right? You want to learn something that clearly separates the two classes. How many of you have seen this picture? This is so common, right? This is what, when we talk about neural networks, this is what comes to our mind. And yeah, we are going to teach at least multi-layer perceptron. I don't know. I'm sure many of you don't know what that means, but we'll see. We'll see the simplest form of neural networks in this course. So far, I have talked about supervised learning, and let's talk about the unsupervised learning that we are going to talk about. So tell me, what is a problem? So far, all the learning I talked about is related to labels, right? Put a label. What if I don't have labels? Let's say I give you 1 million documents from New York Times, and I tell me what are the topics that are discussed in this 1 million documents. What do you do? Okay, and then groups and clusters, right? You try to find commonalities and then you try to find clusters. So clustering is a classic problem that we can do in unsupervised setting. You just try to see what are similar, what are dissimilar, cluster them, and then try to really understand what they are, and maybe put a label later. So that's what proximity measures do. So it's basically looking at distances, similarities between two different points. And the points are essentially numbers. And numbers are what we convert from real life data. Right? So we are going to teach proximity measures. And based on that, we are going to learn at least one simple clustering method. We may learn more. That depends on you. But that is called the k-means clustering, where if you tell k, the algorithm will automatically try to figure out that k clusters. Okay? Okay. That is what I have in plan for this semester in terms of machine learning. But I'm always willing to give you more content and more assignments if you want. Okay? I'm going to give thanks to Professor Balkan because I'm going to borrow a lot of content from her lectures, and many of the slides will probably be copied or at least modified from her. So that's a disclaimer I have, and I will also have that on the slide, but just wanted to let you know. And feel free to look at her website if you want to learn more, but you don't have to. I'll be covering topics and all, but just a heads up. Do you know this person? It's kind of the father of machine learning kind of figure. It's very popular, and we are going to follow some of the contents from his book, Machine Learning by Tom Mitchell. He's a professor at CMU. That will be one of the books, but again, books are something that you may not need. It depends on how you. Well, if you really need the books, that will basically mean I failed to teach what I wanted to teach. But feel free to get these books, but probably you don't need. Plenty of contents of machine learning free online. There is another book from Bishop, and I will try to see if I can share some of the chapters like for free with you for learning. Let me see. So this is another book from where some of the contents will be based off. Okay. So back to scaring. I think I have put that into the syllabus as well, but then again, I want to emphasize this again. Advanced programming with Python. I put advanced, but that definition is subjective. What it means is, if you can think of an algorithm, you should be able to write that in Python. That's what I need. If I tell you an algorithm, if I give you an algorithm, you should be able to code it in Python. We are not going to teach you how to do that. Okay? Because, well, if you think like, okay, I can do it in Java or C, your life will be a little hard to complete those assignments in terms of the timeline that we are looking at. Okay? The second one, the probability and statistics. It's best if you have taken the Stats 3600. It's okay if you haven't taken that, but you really have to have a good basic understanding of probability and statistics, okay, in order to process the contents that are coming forward. It will be theoretical. The kind of cool demonstration that you see of machine learning is going to only happen probably in the project at the very end. But in the initial lectures, we'll be doing probabilities, maths, and all that. It's not going to be so cool, if you define cool in some sense. Okay? Linear algebra, data structure algorithms, that's the basic need, right? The core need here is you need to understand how algorithms work, and then how you can convert an algorithm into a Python code. These are the minimum things that I'm requiring for this course. The most important slide. How do I get an A, right? Okay, so last year, I think, let me tell you that later, but this is how you get it. So we'll have 9 assignments. That's a lot, I know. But that's the only way to learn. So we'll have more assignments, probably every one each week. And we'll have a project that will be 30%. And then we'll have 2 exams, probably 15%, because based on my experience, the scores are pretty low. I'll try to make it easier, but I don't know how far we can go, but that's why the weights are low. The dates are October 3 and November 28. So please lock in those dates. Let us know as soon as possible if you are not available or traveling for some particular reason. If you are not available, you are going to a conference or something, we need to know that early. Okay? So these are the dates for now. Any question on this grading policy? Yes?
Not on the policy of grading, but midterm and the 2 midterms, what's the format of those? Are you coding based?
It will be paper pen writing. So we can ask you to write probably pseudocode max, but we are not going to ask you write a Python code or do coding on the class. The exams will be like in this kind of setting, where there is a paper, you just write. And we want to make it more conceptual than asking you to write exact code or asking you to like compute numbers. That's not the goal. Yes?
So for the 5,000 level course, there's nothing for a final exam. That we won't have anything that week?
No, and there is nothing for 6,000 level as well. There is no final exam. The difference between 5,000 and 6,000 will be in the term project, and I will describe that. For 6,000, it is going to be more challenging. How to make that challenging, I will talk more when I describe what the goals for the project are. Yes?
And the term project is a group assignment?
Yes.
Do groups include people from 6,000?
No.
So it's just within your own group?
Yes.
Got it.
Yes, because the requirements are different. For 5,000 and 6,000, I kind of gave a spoiler, but the project is here. So group project is going to be maximum 3 members, and you cannot group across sections. Distant students only with distant students. In class 6,000 only with in class 6,000. In class 5,000 only with 5,000, because requirements for 6,000 is too high in terms of project. Okay? All right. So last year, 30 students got A out of 53, if you are looking for a number. But guess what? I kind of added plus 30 to everyone out of a 0 to 100 scale to make that.
Could it be me?
I can do it again. But don't panic if you are like running low on score. That's what I want to tell you. The goal is to learn. But I know people will panic and they will come to me and again. But yeah, just I want to give you a sense what happened last year. Okay? But that doesn't mean collectively stop working, hoping that I will add everything to everyone. Okay? I'm not artificially intelligent. I'm naturally intelligent. Okay? All right. Assignments. I mean, you have seen these names, right? Just convert them into assignments. And today, assignment 0 is already out. You can see on Canvas, and your time starts today. And the deadline is on, I think, August 22. And you will get a better sense. If you do that assignment, the kind of background I'm looking for, that will give you a better idea, like, oh, yeah, is this a really, am I ready for this course right now? Okay?
A question about the assignments.
Yes.
Do you limit our resources that we can look at for completing the assignments?
Like ChatGPT?
Yeah, like ChatGPT. I mean,
If I tell you that you cannot, like, can I ensure that you have not?
I'm going to. I'm
No,
just asking,
right.
if we use it to kind of debug just certain lines, you know what I mean? If we reference it and say, hey, like I wasn't sure how to do this, and then I used a large language model
You used a large language model to understand that concept?
to work through maybe an arrow dealing or something.
I see. Yeah, so first of all, I know I cannot, it will be unfair to stop it, like say, like don't do it, because I cannot judge how far you have done, even if you do it. So it's open. Use any tools, AI tools that you would like to use. That's fine. But what I would like to see from you is you even if you go through those large language models, you try to understand the steps. So the goal is to understand. The goal is not to fight with you as a teacher. I'm not here to fight with you. I'm not protecting some gates, and I will not let you through that. That's not the purpose. So use whatever resources are there. These are assistants and to help you learn better. Whatever learning tool helps you learn better. And for some of the materials you will find in Professor Balkan's website as well. Her lecture is there as well. Maybe listen to that as well. Maybe she's a better teacher, right? Yeah.
I'll go ahead. I forgot what I was
Sure.
saying. I have another one, but it'll come back to me.
Oh, okay, sure. Exams, 2 exams. October 3rd, November 28th. Again, please lock in those dates. All right. So time for introduction to TAs. So we have 2 GTAs in this course who are painstakingly standing for a long time because we don't have seats. But yeah, so let me welcome Sri Ram Pavan Kumar Gutikonda. So Ram, please come here, introduce yourself, and then we will go to Puya.
Okay, hello everyone. So I go by the name Ram, as you can see, and I think there is not much to discuss because you got a very good introduction from the professor. So I just want to discuss about the office hours. As you can see, like we are planning to have every day one office, like me or my co-TA, like we are going to have an office hour every day, and my office hours are on Monday and Wednesday, and he'll let you know about this one. And you can contact me by mail, and the office hours will generally take place at the Shelby 2319, if you all know it. And yeah, apart from that, I don't think there's much introduction needed. And yeah, good luck with your course, everyone.
Yeah, so 2 more things to add. Like Ram is one of my PhD students working with me. And you also took this course last year, right? Don't tell anything about it. Okay, good. Yeah, Puya?
Hello everyone, my name is Priyan. I'm doing a PhD here in computer science, and my office hours will be like Monday 2 to 3 p.m. and Friday 11 a.m. to 12 p.m. Yes. And 2319 Shelby is on the west wing, and hope to see you all during the semester. So we'd like to see your course and everything.
All right, thanks. And this is me. The classroom is already this one, you know. My office hours will be on Tuesday and Thursday, right after the class. Because I know after classes you will have questions anyway, so that's, the office hours will be from 3:30 to 4:30. My office room is Shelby 3106. So this slide will be on Canvas anyway. If you don't remember, that's fine. And yeah, you can always reach out to me on email, on Canvas, messaging, whatever you feel. And I think that's it. So, how many are scared up until now? Not yet. All right. So, see you on Thursday. No, this is Thursday. See you on next Tuesday. All right. See you then.